Which instruments are you repairing?
Sir, I am trying to set this signal generator right.
What is wrong with it?
Well, that's what I am trying to find out.
Did you ask the owner of the instrument as what problems he had with it?
No, I didn't, as I can myself find it out.
Well, that is not the way. You must always ask the customer as what problems he had with the instrument. We have a standard set of questionnaire which should be filled before taking up repairs.
Well, in that case, sir, do you have any such form with you?
I'll see in my files if I have one. Here it is. You can also have a look at it. You can go through this.
Whenever you receive an instrument for repairs from a customer, always collect some information by asking questions like, what defect did you observe in the instrument? How is the defect apparent? You can find out from the customer if other instruments plugged in the same socket work well or not. Is it always this way? Does the defect occur in the same way? By this, you will be able to know if the defect is intermittent or a direct failure. The next question could be if there was shock, smoke, or any noise when the defect occurred. The owner could be asked whether the defect occurred suddenly or gradually. Thus, we can find out whether the defect was due to aging or a direct failure. Another question could be whether the particular defect had any effect on other functions. One must know if someone else had tried to repair the instrument. Repair by an unskilled person may lead to a number of complications. One should always stress for the service manual of the defective instrument. Service manual is like a road map which helps you reach destination without wasting time.
So, you make it a point that you should gather these informations which will make your troubleshooting procedure much simpler. After taking down these informations, relax. See the service manual if you have one. Now let us see what is wrong with your instrument. The instrument is on and the output is also properly connected. Let us now see its sine wave output. I change the sine wave square wave selector switch onto the sine wave and observe the output on the scope. I find that sine wave section seems to be okay. Let us now see its square wave output. For that, the selector switch should be kept at square wave and the output should be observed on the scope. Well, in this case, you don't see any output, which means that either square wave section may be faulty or even the sine square selector switch could be the culprit. Do you have its service manual?
Yes, I do have with me, sir.
While observing the block diagram carefully, we see that it has 4 major sections, which are sine wave oscillator, square wave generator, meter movement to read the output, and the power supply. Out of the 4 sections, square wave generator section may be defective, or even the sine square changeover switch may be faulty. You can therefore isolate the defective section by associating the symptom. This technique is known as symptom function technique. So you see how to analyze a defective section by associating the symptoms with the functions. And what you need there is a small computer you have in your head. Is this table lamp plugged in? Yes, it is connected. If I switch it on, the lamp should glow. Oh, this is not glowing. I'll see if this is a switch problem. This doesn't look like a switch problem. Now I'll have to check whether the plug is properly plugged. Let us switch it again. Here it glows. So you have associated the symptom with the functions and could trace a simple fault.
In electronic instruments, the relation between symptoms and their functions are not so simple. But by understanding the various functions and the way they perform, it is possible to find the fault by reasons alone in most of the cases. Let us take an example. In this case, we have a number of inputs all going to a single output. We can easily isolate the faulty section by analyzing. If input 1 is applied, we get the output. Similarly, when input 2 or input 3 is applied, we should get the output. The defective section can be easily isolated. Let us take a case of a FM phono pickup system. In this case, we have 2 signal inputs: the phono pickup and the FM tuner. Then it has preamplifiers for phono pickup and FM radio respectively. And finally, it has an output amplifier. The power supply delivers the required power for each circuit. Looking into the block diagram, a symptom function chart could be made. This particular tabular format gives us an idea of the symptoms and the possible functions which could be defective. as in the first case the turntable does not turn, whereas FM sound is okay. The function defective could be the motor. In second case, if there is no phono sound and FM sound is okay, the troubled portion could be phono pickup or phono preamplifier. In third example, if the turntable turns without any sound, the fault could be either of power supply or an output amplifier or even a speaker. In fourth case, if the FM sound is not available and phono pickup sound is there, the faulty section could be FM tuner or FM preamplifier. Other than the major faults, there is also a possibility of minor faults which sometimes go unnoticed. For the first case, a motor may be good, but the turntable may have struck or drive mechanism may be slipping. In second case, a phono FM switch could be defective. In the third case also, the problem in phono FM switch could cause the same symptom. In the fourth case, the antenna could be the culprit. Thus, you can analyze the fault and can find the defective section by this technique.
So far, you have learnt about symptom function technique to trace out a defective section. Next time, you will learn about signal tracing method, voltage and resistance method, and finally, substitution method.
Thank you.